Let's take a look at a lab problem from your lab assignment. This is 11.2, problem number 1. Determine whether the geometric series is convergent or divergent. If it converges, then find its sum. So the fact that this is a geometric series means that we should be easily be able to tell if it's convergent or not, and then if it does converge, we should be able to find its sum. Alright, so our series starts off with 8, and then we have minus 11 plus 121 over 8 minus 1331 divided by 64. Okay, so to see this as a geometric series, we have to rewrite this as a times some ratio r raised to the n minus 1 when your series starts with 1 to infinity. So if you take any two terms right next to each other, provided that the series starts with 8, if you take two terms right next to each other, you can write them as a ratio or a fraction, a times r to the n divided by a times r to the n minus 1. And then it's clear that the a's will cancel, and then there's going to be n minus 1 r's that would cancel up here in the numerator. That would leave you with 1 r, and then all the n minus 1 r's in the denominator would cancel. So all you would have left is r. And so this is going to give us a clue that if we divide two consecutive terms, in this case they're dividing 1331 divided by 64 negative divided by the term right before it, 121 over 8. Well, if this were the case, I can really just divide negative 11 divided by 8, or I can divide 121 divided by negative 11, and in any of those instances you should have the same ratio. So first of all, I think the ratio is going to be negative because each two consecutive terms has one positive, one negative. And then I have an 11 over 8. If you look at this and work this out, 131 is actually 11 cubed, 1331 is 11 cubed, 121 is 11 squared, 64 is 8 squared, 8 is just 8 to the first power. So you'll see that it'll amount to negative 11 over 8. So in the series, the n is equal to 3 term is 121 over 8. And so this is if this is equal to ar squared, then that's 121 over 8, and it's positive, and then there's no other numbers out here, so a is just going to be equal to 1. Oh, it's not going to equal to 1 because there's 11 squared, and then this is 8 squared, which is 64, but then your actual term is 8, so we need to cancel one of those. By the way, another way to find the a term is usually just look at the first term, and that's your a term, because the first term of your series is going to be a, and then the second term is a times r, so the ratio doesn't start happening until the second term, which means the first term is just a. Alright, so I think this a term is 8, and then all we have to do is similarly here we have another 8, because you have 8 cubed in the denominator, but you want 64 in the denominator, so you have to undo that by multiplying by 8. Okay, so now we know it's a geometric series, and we know for geometric series that if r is bigger than or equal to 1, or bigger than or equal to the absolute value of r is bigger than or equal to 1, then the series is going to diverge. If it's less than 1, strictly less than 1, then it's going to converge. So this is going to diverge, and since it diverges, this thing does not exist. So that's all there is. Okay, I hope that helps.